Hi class, welcome to another quick review. This is going to be specifically about pi. Now it won't be long because even though pi is really important, there's not a lot of particular facts that you need to know about pi. So let's get started. This is the mathematical symbol for pi. Now I'm sure you've all seen it before in your geometry classes, maybe a trig class that you've taken. I know you've seen it in algebra, and you will see it in the future in calculus. It's a little history lesson. Pi, the symbol specifically, is in a letter from the Greek alphabet. So it's a Greek letter from the Greek alphabet, and it was first chosen by Professor William Jones in 1706. Now, no one really cared about William Jones, which is unfortunate, but it wasn't consistently used until 1737 by Leonhard Euler, who is a really prominent mathematician, and I'm sure you'll hear about him later. But anyway, so ever since 1737, they have used this very consistently throughout all forms of mathematics. So this is the mathematical symbol representation, if you will. Now this is the the decimal representation of pi. Now as you can see, this number goes on forever and never repeats itself, and that's the two things you need to remember. Those are the qualities of an irrational number. A number that goes on forever and never repeats itself. Now if you want to pause the video here and just take a look at all these numbers, you'll find that there is no pattern. So no one's lying to you about this. There's no pattern, and it really does go on forever. Or if it stops, no one's been able to find the end yet. Because essentially, one number can go on for an infinite amount of time. We just don't like to use those numbers because you can't calculate them easily, obviously. So yeah, just remember, goes on forever and never repeats. And that is the definition, practically, of an irrational number. So really briefly, let's go over what pi actually is. Pi is the ratio, or the fraction, of the circumference, so the outside ring of the circle, and the diameter of the circle, so the line that goes all the way through the middle. Now remember that we learned about the radius. The radius is only half the circle. The diameter is the whole thing. So just remember that. The whole thing. So the whole outside and the whole middle line through a circle. That is pi. So once again, to sum it up, pi is the ratio of the outside ring, so the purple part, and the line through the middle, and so the green part. And at the end of the day, it equals pi. 3.14159. And I mean, I'm sure I'll say that in class several times. It's got kind of a ring to it, and it's a good way to remember it. So, the outside ring, the line through the middle, 3.14159 pi, or pi equals 3.14159. Anyway, just remember that. You'll use it for the rest of your math career, okay? So here's our quick test question. Ooh, this is one way to pick up an extra point on the test. I might even ask a bonus question about what I just talked about. So you just never know. Maybe watch this once or twice before the test, and you're golden. Anyway, is pi, 3.14159, rational or irrational? Now think about what I had just mentioned earlier. And if you don't know, just guess, and we'll talk about why it's wrong. I'll give you some time. Pi. Ha. Anyway, yes, you are probably correct. The answer is pi is irrational. Why? Well, because like we talked about, it goes on forever, okay, and it never repeats itself. So a good counterexample of a rational number is 1 over 2, or 1/2. So first of all, you have two precise integers, 1 and 2. And then it ends. So the decimal representation is 0.5, right? And it ends. And it never repeats. And it's perfect. That's a rational number. 1/2 is a rational number. Pi, on the other hand, is a total opposite. Irrational. So just remember on the test, if I ask, is pi rational or irrational, and I ask why, you say irrational because it goes on forever and it never stops. 3.14159. Anyway, thanks guys. Thanks for watching. Feel free to watch again. And I hope you do excellent on the test.